trajectory P, make sure you're on project net.
Copy. Flight GNC.
What GNC?
We have a good net.
Copy, good in it. Alright, all stations. This is flight on project net. TV is go for drop. I repeat, the TV is go for drop.
Drop in 1 minute on my mark.
Mark 60 seconds.
Check 115.
Now we're going to hold it out.
Mark 30 seconds. System is armed.
Drop
Mark
in
10 seconds.
9, 8, 7, 6, 5, 4, 3, 2, 1. Drop.
Separation confirmed.
Separation confirmed. DVR is recording. Ignition confirmed. DVR is recording. We have stable flight.
Copy, stable flight.
I recorded good job dropping my script, so. No, I mean,
Mach 1. Good. Mach 2. Vehicle stable. Mach 3. Vehicle stable. Acceleration is good. Mach 4. Mach 4. We're not detected.
Yeah.
Yes. 1. Expected VT2, 899 meters per second.
Residual spin rate, 2 degrees per second.
VT1 detected.
Yeah.
Yeah. Good. VT2 detected.
Good.
here he goes. Come on, baby.
Here goes. No.
Flight, this is PI, partial shoot. Copy, partial shoot.
RD, this is TC on Project Net. RD, this is good copy. We had a partial shoot. So RD, move over to anomaly 1 and coordinate with trajectory on movement of the ships. So RD, move over to anomaly 1 and coordinate with trajectory on movement of the ships.
RD, this is trajectory. I have a special location. 22, 48, 29, decimal 0. Longitude, negative 160.
Avionics flight?
Flight.
How much longer do you have for time shutdown?
Touchdown, about 15 minutes.
TC, this is MD ASCent.
Copy that, MD.
TC, this is BPO.
That MD.
TC, this is BPO.
Go ahead, BPO.
Yeah, TC, I got a best estimate on balloon impact, lat and long. If you're
Go ahead, BPO.
Yeah, TC, I got a best estimate on balloon impact, lat and long. If you're ready to copy.
Let's go ahead and move this over to TechNet.
Roger, go TechNet.
Yes, sir. I got 22, 48, 29.
Minutes to time shutdown sequence.
At last known location. TechNet and provide last known location.
One minute to time shutdown. Ten seconds of time shutdown. Copy. 10 seconds, Avion. DVR, stop recording. Copy DVR, stop recording. Seconds to fur cable cut.
For a cable cut.
Good for a cable cut.
Ordnance shutdown.
Our confirms. Confirm ordnance shutdown.
And by for altitude trigger for altitude shutdown.
$28,000 feet. $27,000 feet.
And as we can see, the LDSD test is complete, and they are in the process of shutting things down just prior for the vehicle to enter the water as it drops down, shutting all the systems down, so cameras and all data will be protected.
24.
Dan, go ahead and explain to us what transpired through the test and how things went.
Sure. So first off, it looked like our rockets fired correctly. Looks like we got up to the altitude and the speed we were looking for. We heard the call that we were in stable flight. We heard that we got up to Mach 4. So looks like we got the condition that we wanted to. The SI had inflated, and of course, it's too early to say exactly how it performed, but it looks like it performed great. What we're seeing now on the screen now is that we're getting down to lower altitudes, and so the pressure is higher outside the side, and so that makes it flap around. But while we were actually using it up at altitude, it looked like it was performing very well. The parachute, though, we heard that there was a partial shoot. So that tells us that the parachute deployed, but there was something that happened with its operation that wasn't expected. It was a little bit hard to see exactly what was happening in the sort of low-resolution feed that we had. And so that's why the team is going to take a look at the high-resolution video that we're going to get back along with the rest of our data to make a determination about what's going to happen. Box aboard the vehicle, which has all of that critical data. It's really a gold mine of important data from this test. That's going to separate off the vehicle. It has homing beacons on it so we can find it and fish it out of the water. And so that's really the top priority once this splashes down, is to get that black box out of the water, because that's going to tell us exactly what happened with the parachute and everything else in the test.
So
once this splashes down, is to get that black box out of the water, because that's going to tell us exactly what happened with the parachute and everything else in the test.
So we just saw that the systems have shut down in preparation of splashing down into the water. This is a great example of understanding how we test and why we test. We have to push the envelope to the max to learn as much as we can.
That's right. This is exactly why we do tests like this. Spacecraft to Mars, we know that they're going to work when that big mission is on the line.
Roger, I have LOS on the radar. Stand by for...
And a reminder, this is the largest parachute ever tested. The parachute that went to Mars with MSL was the largest that we had at that point. And this is the largest supersonic parachute tested. The parachute that went to Mars with MSL was the largest that we had at that point. And this is the largest supersonic parachute to get to the next level.
That's right. It's about twice the area of the parachute that was used with Curiosity, about 100 feet in diameter. So it really is a very, very large parachute that we're testing.
And we will have more information as things transpire. There will be a news conference planned tomorrow, I believe, at 7 a.m., 1 p.m. Eastern Time. That's when Mark Adler, the project manager, and Ian Clark, the PI on LDSD, will be able to give us a little bit more information. But right now, we basically have what we could see, and again, we do not have high resolution to tell us all that much. Okay.
Go ahead, BPO.
Yeah, no, TC, I know you got your hands full right now. Do you have any idea of location, time for a hot wash on this?
Okay.
Go ahead, BPO.
Yeah, no, TC, I know you got your hands full right now. Do you have any idea of location, time for a hot wash on this?
Stand by. Let OC get this coordinates for the splashdown location, then I'll work on a hot wash.
Good copy.
So as we're standing by for the splashdown, let's
have cameras that are stationed to actually witness the splashdown event. So we're not going to be able to see that. But we do have boats that are going to the site where we're projecting the vehicle is going to splash down. And then we're going to fish everything out of the water because we really want to But we do have boats that are going to the site where we're projecting the vehicle is going to splash down. And then we're going to fish everything out of the water because we really want to understand how operations last year, which show various elements of the test in the water. So this is the parachute from last year, underwater, and this was a diver that was in the process of recovering the parachute, snapped this great picture of the chute while it was down there underwater. The next one shows the balut. That's the item that's used to pull the parachute out. Floating in the water, and we've got snorkelers that are swimming out to go recover that balut out of the water. The next that are swimming out to go recover that balut out of the water. The next one shows the entire test vehicle being crane lifted out of the ocean and then onto the deck of a boat. So you see that big nozzle of the Star 48 rocket. You see the SIAD there. At this point, it's pretty limp, just sort of hanging there loosely, having already done its job. And the vehicle is sort of dumping ocean water as it's being crane lifted onto the boat deck. And we have another picture that I think shows the parachute being dragged in. You see it's a lot of work to get these things out of the ocean and onto the boat. So a whole team of people dragging this parachute out of the water. And then here's another view of the parachute being hoisted into this recovery boat. And you can see the test vehicle there in the background on the same boat, having already been recovered. So that's really the next step for the team this year. Those are the pictures from last year. And those same things are going to happen here as those boats move out into position in order to fish everything out of the water.
Now, this was the second LDSD test, but there are 3 planned, and there is still yet another one that will take place a year from now in the same location in Kauai, Hawaii. It's anybody's guess at this point exactly what will be tested, but there is a possibility that we may try testing a brand new SIAD. We've already seen SIAD-R working well in two tests already. Is there a possibility of a new SIAD?
There is a possibility, yeah. We have a totally new design of SIAD that we've been working on in parallel with the SIAD that we've seen here today. And so there's a possibility that we'll test that side in the test next year. We're not sure, though, what we're going to do exactly in the test next year. It's going to depend a lot on the analysis of what happened here in the test today. So the team is going to spend some time with the data, understanding what happened, looking at the video, looking at all of the instrumentation data, and coming to some, firm conclusions about how everything performed. And that is going to inform the choices about what we're going to do in our supersonic test next summer.
All right, so we have some video of that Syad-E. We might be able to roll it. This is part of the work that you've been working on with the LDSD project.
Yeah, that's right. So this is another rocket sled test. This is the Syad-E. It's a larger version of the Syad. The design is somewhat different. So here's a slow motion view of the Syad deploying. It actually has inlets that are open to the air. You can see them well in this view here. And so those ingest the oncoming air and help it to inflate. That's different than the Syad that we tested here today, which is a sort of a pressure vessel, a donut. So here's different views of that Syad deploying in slow motion. It actually only took about 1 second to deploy. So it was traveling pretty quickly down that track again to make sure that it's strong enough to withstand the forces that it would see in a supersonic test.
So that wraps up the main order of business for today. The test, the vehicle's cameras have stopped, and they will be off until the vehicle hits the water. It was to be shut off. All power is off until the test vehicle hits the water. Shut off. All power is off until the test vehicle hits the water, and boats are on standby to retrieve the vehicle, and they won't be back to shore until sometime tomorrow. And there will also be a telecon tomorrow to report and follow up on what happened. That will be at 7 a.m. Hawaii time, 10 a.m. Pacific, and 1 p.m. Eastern.
Element leads, I repeat the
All right, and we are going to sign off soon. Our thanks to Dan Koda, our awesome LDSD commentator, and the whole LDSD team that includes partners from 3 NASA centers, JPL, Marshall, and Wallops, and of course a big thank you to the U.S. Navy Pacific Missile Range Facility. And we leave you now with a video on Syad-E, which very well may be one of the next technologies that could be tested on the next LDSD project. This is a video produced by Dan Koda of this year's Syad-E sled test. Thanks everyone for joining us, and if again you want more information, check that website. Thanks for joining us. Of this year's Syad-E sled test. Thanks everyone for joining us, and if again you want more information, check that website. Thanks for joining us.